If your code looks something like this, then you have a problem. No one can understand your code. As in, it's all messed up, it's all messy, all over the place. As Martin Fowler said, any fool can write code a computer can understand. However, good programmers can write code humans can understand. And with this code, a computer can understand it because it can draw the spider web, but a human can't because it's all messed up without structure. Here are 5 ways to make this code much better. Number 1, structure. To make your code structured, look at each part of the code, ask yourself, what is the purpose of this part of the code? And then group together every line of code which contributes towards that purpose into that section of the code, whether it be beginning, middle, or end. For example, in my spider web drawing code, I can start with the preparation steps of setting up the turtle system, which I will call configuration of the code. I will move the turtle setting commands here at the beginning, for example, here, like this is a set it here. I can do it this way. Then here, that's good. And then I could just say here with the turtle, not the screen. I'm going to keep the screen separate from the turtle configuration. Oops. And that's it for the turtle configuration. And now I'm going to continue on with the end of the code. We've created a resin at the center to represent the spider. So I'm going to move the here, and then here. This is all configuration for creating a spider. This is actually creating a spider. And I've used turtle here instead of spider, which is the closest I could get. And also, I forgot I should move this variable at the beginning because this is part of configuration for the pixels and for the gap between every spider. And so that's done. And then what we have in the middle is the loops and commands to draw the spider web. They are in the right place. And that's structure and done. With structure in place, the next steps to making your code more readable has become much easier. And that leads us to number 2, comments. With structure already in place, adding comments to code is much easier as now it is a matter of just stating the purpose of each section of code instead of repeating yourself countless times explaining code that's all over the place. In Python, to indicate a comment, you add a hashtag before the comment you want to write out. It only works for that specific line number, so if you want a new line for comments, you need a new hashtag or you will just get an error message. For example, the purpose for the beginning of the code is configuration. So let me add that here. This is configuration. And as I said, it only works for this specific line number. If you want to still add comments for uh, like this of the code, you get an error message. As you can see, there's an error message. So here, invalid syntax. So you need a new hashtag for that comment. And then in the middle is drawing the web itself. So drawing the web, and then at the end is creating a resident for the web, or rather, turtle representing the spider. Spider creation representation. As you can see, it still works. It still draws a spider web. Uh, but there's also other uses for comments. For example, it could be used to explain specific lines of code that are particularly difficult to understand. And when a computer sees a comment, it skips over it, meaning that the computer just ignores it and doesn't care. And about to explain specific lines, explain a specific variable, gap for the for the spider web in between each capture spiral. So there are 8 arcs here, and that's a capture spiral. The point is, it's added an explanation for the variable, and also if you're testing stuff out, you can add some commands here. Let's say turtle.screen.bg color blue here. So that way, if you're testing which background color looks better, you can do it like that. But we'll move it back to the original. And here, and the code still works. There's no syntax error. Which leads us to number 3, variables. Either you use bad variable names or you don't use variables at all. Using variables help describe what specific values are about if you do it right. Even if you don't, it will still help with editing and improving the code, where if you have to change A to B 100 times in the same code, variables mean that you don't have to do the same thing 100 times. If I wanted to change the gap at A to 25 rather than 24, I could just go to the variable and change the value assigned to it, instead of having to do it manually thrice where A is used. And then we'll see it can still run. It still looks like a spider web. There you go. I could change it then to 30 to affect the code a bit more, as you can see here, where variables have made my job much easier. Now it's been shifted to the right with more noticeable change, and it just took one line instead of 3. I'm going to change it back. However, any fool can write code the computer can understand, but good programmers write code humans can understand. As of now, variable A is only understandable by computers, but if we change the variable to capture spiral gap, it creates an error for now, but it is understandable for humans. Well, let me fix this error first, and congratulations! You are no longer any random fool, but now a good programmer, because humans can now understand your code. But let me fix the turtle.ped thing. We'll call it spider. Now we are really good programmers. But to become better. Number 4, modules. Modular programming is a no-brainer. Not only does it make code clearer, but also easier to edit. But what is modular programming? Modular programming uses subroutines, which are functions or procedures, and then calling them to run the code within the function and or procedure. So why aren't you including them? No! Using less lines is not a good reason not to use modular programming or anything previously mentioned in this video. Making code short does not make it easier to understand for humans, but only for computers, which makes you any fool, according to the saying, by saving a tiny fraction of memory space at the cost of readability for humans. Good programmers never do that, but instead make their programs modular based and human friendly. But how? I told you, use subroutines. I'll show you right now. For example, define capture spiral, point quantity parameter, and a circle radius parameter. Go to move the code. I want to make a subroutine here, and I'm going to change these parameters. So point q quantity and a circle radius. And I'm going to try to eliminate bugs here. Minus 180 divided by circle point quantity. And then go to call the procedure where the loop used to be with the correct parameters. Capture spiral, point quantity, and 10 plus 10 times I. And I messed up. That's okay. I haven't defined point quantity, of course, but we'll just change it to a number, and we made a mistake. It's okay to make mistakes. Making mistakes does not make you a bad programmer. So the error here is I used 180 here when it's supposed to be 360 here. So that's debugging, and there we go. But more importantly, it's easily editable. For example, I could change the number to 7 without any problems or bugs, except that here we have a bug. It's a slightly off center. Instead of using capture spiral gap, we're going to use 3 types point quantity, and instead we're going to change capture. We're actually going to abandon the variable, and then we're going to name it 7 times 3. And problem solved. Now we have a 7-point spider web. It's going to be easy to change. So, yay! Hip hip hooray! But there's one thing we need to do before coding to make all of these steps in the video easier, and that is number 5, design. Plan your code. Always plan before you write. It's a smart thing to do. It will make the writing easier. It's the same with code. Planning and or designing code is done using flowcharts or pseudocode. But if you need to do a quick plan, I recommend using flowcharts, as you can summarize code in sections and write the purpose of the sections in each box. I will show you an example right now with this code. On to pseudocode. Pseudo means fake, so pseudocode is fake code. Pseudocode is halfway between human language and computer language. Good pseudocode writing is required for exams, but there is no convention for pseudocode. So if you are short on time, you can skip certain blocks of code and replace them with the purpose of these blocks of code instead. I won't go into pros and cons because for quick plans, there's no benefit to using one over the other. Here's an example for pseudocode for this code. And you can see how I'm guilty of all 5 of these mistakes in this video here.